Well, hello. Welcome to the Carbon Series podcast, hosted by US Energy. I'm your host, Jason Marmon, and I have a very special guest, a Kiwi from New Zealand, Professor Susan Krumdieck. Thank you so much for being on the show today.
Sure, I'm glad to be here.
I'm like super excited because we had met on LinkedIn, and you are a 20 plus year mechanical engineering professor, I should say. You're the chair of the Energy Transition Engineering Department with the University of Heriot-Watt University, or I should say Heriot-Watt University of Scotland,
Yep.
correct? And so
Yes.
you have so much, I mean, just from the little time that we've talked, I think you got 100 peer-reviewed journals and scientific papers, and from what I'd say, the authority on energy transition engineering. And so when I say that, what does that mean? Energy transition engineering.
Right. Well, what we know for sure is that when it comes to extracting free goodies from the earth and turning them into wealth and cool things, that the way we've always done that is boom and bust. Yeah, go
Very
get
familiar.
it as fast as you can. Invest in research to be able to get it faster, and of course, drive the demand for the product up. And it always seems to come as a surprise when you get to the peak in production, and the production starts to fall off, and you have a big collapse, and everybody's sad, and governments have to step in and do something. But it's never actually a surprise. So when you look at oil being the big underpinning of the way that our entire world works right now, and the fact that it is also an extractive industry and it has its own boom and bust development pattern, then for myself as an academic, I went into academia because of curiosity. I just want to find stuff out. And for me, having grown up in southwestern Colorado, actually surrounded by the Anasazi ruins, that whole thing of where do civilizations go? How does this happen that these people aren't here anymore? Connecting that up with energy, I would not say I'm a doomer at all, because whenever you see a civilization that we think has collapsed, that's not really what it did. It changed. It was doing something that it's not doing anymore, but it changed. So for me, you put those together, here's our big civilization based on something that will change within my lifetime in a profound way. And as an engineer that works in energy, what does that mean to our field of energy engineering and all of the fields that tie into energy, because they all do. And so that's a huge space where I believe we're at a point now where that field is going to take off, because that's where we're at.
Yeah, and just a little backstory from me. I'm from a town called Williston, North Dakota, which is actually, they branded it Boomtown, USA.
Oh,
And
you know what I mean then.
and then so when it goes into Bustown, USA, then it's like, well, we probably shouldn't have, branded it this, but they are transitioning from, now it's hometown, or something along those
Oh,
lines.
okay.
So it was a very
Please stay.
10-year period there, but yeah, so where I'm from is very oil and gas focused, and you have like a, very fact-based orientation with, where the industry was, where it is and where it's going. And oftentimes the culture of oil and gas makes it very difficult to have authentic, genuine conversations about, all right, this is where we're at, this is where we're going, but most recently Shell came out and said, they've arrived, or they were already at peak oil. And so what does that mean for the transition, that you're working on?
Well, it means that finally the rest of the world will catch up with where I've been looking. Because yeah, 20 years ago, just really thinking, okay, for my career, I want to study this transition period and what it means for what kind of engineering tools, what kind of economic models, what kind of social understanding, what policy contexts are going to arise in this period. And so purposefully making ourselves look at the peak and decline of oil, hopefully sooner rather than later, because that fuel is amazing. And just blowing it all in 1 century seemed like a very irresponsible thing in the context of humanity to do.
Naive,
But be
ignorant
that
comes
as
to
it may,
mind.
it's always a transition, whether you decided to do it or it just happened to you. So I actually moved to New Zealand to do that research, because in the US, that understanding was going to be about 20 years later. That, okay, that's where we're at. And the fracking boom really delayed that understanding, because you know, in that huge upswing of being able to extract the tight oil, yeah, you just, again, looking forward for human beings. Here's the thing I think I've discovered: our ability to look forward realistically has not been well developed in our evolution.
It's
In
what can you
fact,
do for me
maybe it's a
now?
protective thing. If we look forward, we can see ourselves not being there anymore, and that's not fun.
My
And so we aren't good at it. We're much more in the moment type of folks, and relying on what we know works right now in order to decide what to do. And so that's why we've always been these boom and busters. We just can't seem to see past it. But here we are now. We now understand what's going on. The fracking is not going to be a thing that's going to continue on an upward swing forever. It's also a boom and bust.
it's very
And
expensive too. Like
yeah,
very a lot of inputs that go into this. And you had kind of talked to me about if we are looking at the bust or the kind of the decline in demand for oil and gas, what is the oil and gas industry's role in this transition?
well, okay, when I look at transitions, they can go a lot of ways. And the things that we, historically interpret as collapse often have social declines and breakdowns of trade and breakdowns of infrastructure systems. So that way wouldn't be the preferred way. The preferred way would be the understanding of just how valuable oil is, and therefore rearranging the way oil is used to make sure that it's available for essential uses. And that means a new skill for our economy, which is to differentiate between essential and optional. And we like to hand over that kind of responsibility to, and you can use air quotes here, market forces.
Yeah.
But that is not a very efficient way at all to figure out what's important and what's not. So that's a new innovation. Now, here's the thing. When we talk about this transition period, we tend to want to jump to technology solutions, right? There's got to be some technology that leaps into the void and keeps us sailing, keeps things going. And as a technologist, I can tell you that it's not like that. There are things that leap into the void and can help us achieve this transition to a good way of living, to well-being, to actually regenerative economics instead of simply extractive. We still will have extractive industries, but they are to supply essential activities. And that kind of understanding of social behaviors, hierarchy of needs, these sorts of things are all where the innovation space actually is. It's not in new technologies so that we can use more energy or have more or more or more. Anytime you're saying more, you're on the wrong track. You're on a dead end, evolutionarily speaking. So think of words like fit, like elegant, like prosperous. Those things aren't things that necessarily need more all the time. They can be done through, achieved through just better.
And I think you said earlier when we were talking purposeful downshift in oil dependence, and you were saying, production needs to lead. When you look at the legacy, the 30-year legacy of oil, there's not a whole lot of innovation or value adding to, like, an example for us in North Dakota, we're still flaring off natural gas like it's going out of style. And that's very difficult. It hurts my heart, and no one has any answers for me. Like, why are we just burning off our future generations' energy sources?
Yeah, such a valuable fuel. And that sort of pump it as fast as you can in all the aspects. I tell you what we've got is it fair to say an old boy way of
Boys
looking at
Club.
things?
Oh, totally. I talk about it all the time. And in my hometown, it's like, well, if you're not from here, you can't get in the Boys Club. But then I'm like, I'm from here. Like, this is I went to high school, went to college, I played bass. I did all these things for you guys. And now I'm not in part of the club. Like, whose club is it?
Well, that's where, as part of the big transition, I would really look to see younger people coming in with ideas that are not that same old way of looking at
For
things.
sure.
And so we can call them innovators, we can call them transitioneers. And transition engineering is quite interdisciplinary because it's about whole systems. And I think that younger people and women can see the way that all this complexity can work in a way that is so much more nuanced and so much more creative than the old boy way of looking at oil. So if the old boys would happen to find a way to hand over, that would be the
Yeah.
easiest way to go about this transition.
I literally, so I had my last podcast was with Gavin. He's the director of the Houston Advanced Research Center, obviously in Houston, Texas. And I was like, so how do we get the old guard to pass the torch, so to speak? And I was like, is it going to get passed, or do we just have to take it? And he's like, well, it's a good point. I don't know. And so it is frustrating for, young guy like me, like, to where I understand that I'm not the engineering mind that can do all the, the technical things, but I understand that I have one of my best friends is a very gifted electrical engineer, and he's got a lot of responsibilities, just got promoted, working for a big firm, genius. But he, maybe doesn't have the risk aversion, that I have, like, where I've done events, and I'm willing to go, talk to corporate sponsors and things. So we have a relationship, of him being the, a great, brilliant mind in math and engineer, and then me being able to tell the story, go raise some money, put an event together to, have a common goals for, so people can understand. And so young people really do need to be involved, but for us, it's where's the opportunities to be involved in this transition?
Well, the job descriptions won't be in the old oil company.
For
Right?
sure.
Because they don't even know that's what they need. And if you have a look at my book, Transition Engineering, Building a Sustainable Future, make a plug for the book there. What you'll see is that this transition period, that the work of engineering that transition is interdisciplinary. You definitely can't do it just with policy, or just with economics, or just with communication, or just with engineering. All right, everybody has their role. And the very first story in the book, yes, there's a story. There's lots of stories, because we have to make sense of this.
You got to relate.
We don't have the grounding in how to make sense of this. So sense making is why we have stories. We can't be just spending all our time blaming each other, or, saying, well, I've got a solution, when actually it's system change that we're talking about. And that system change comes with the ideation, the innovation of the change. But that innovation also has to be in this complex context. Yeah. So it's a whole new field that you could fill up whole courses full of people from different backgrounds. You have to already know your background. You have to already know your stuff. Yeah. But now you shift your perspective. You find a new way of looking at things the way that you thought they worked, and that's how you get innovation. And then working with people who know how businesses can work, and how to work with communities, and how the environment works, and you put that together. So it might sound sort of pie in the sky, but what I would say, you mentioned the 100 peer review papers. That's us doing this thing that we think would work, and finding out that there's whole new tools, there's new kinds of data, there's new kinds of communication. And so I'm really on a mission to just, I'm not even selling like a technology or anything. I'm trying to get people to just consider a perspective shift. There's not much cost in that. It's only about $60 for the book.
Yeah. Yeah.
So just consider a perspective shift. And if you don't see the opportunities there, then get a few more people and start exploring that space between where we've been going and where we think we're going, and where it's pretty clear we have to go. So there's a big space there for innovation.
Well, let's keep on plugging. So the Heriot-Watt University, they made you the chair in partnership with who?
With the okay, so Heriot-Watt University is in Edinburgh, and it was established as a industrial engineering university, right? You've heard of James Watt.
Yep.
Right. And they are known as one of the best petroleum engineering universities in the world, which I thought was very intriguing. And of course, the North Sea oil and all of that is in there. All right, so the campus where I work is in Orkney, so that's one of the islands up on the north of Scotland, and they have a big project there to transition the Scottish Isles. So there's three of them: Outer Hebrides, Shetland, and Orkney. Transition those islands to net zero by 2030. So if this sounds like a bit of a land people on Mars moment, yeah, it's kind of like that. We do not know this continent that we're going to explore. We know what we can bring with us. We know what we have to leave behind. And we definitely have a lot of interesting new constraints in this new world we're going to. But the whole point is to just work out what life is like there and how to make it all work. And that is seen to be a real way to help the rest of the UK and the rest of the world understand what energy transition is, that it's the change of what you are doing now.
So you are the Captain Kirk of energy frontiers right now.
I'm a co-director with a company. So there's a company that does energy transition exploration. So they've done marine energy, wind energy, flexible demand in homes, upgrading of homes. So sort of in that energy transition space before it was really called that. And so that company that has that background in Orkney, yeah, if you want to look up Orkney, it looks like there's quite a lot of exciting stuff happening there, because they just sort of get on and do stuff, all 20,000 of them.
That's awesome. Well, that's a collective, like that's where you get stuff done, is when you have that many people.
Because like I said, it's complex. You have to actually put everything together in this transition. And so that is easier to do in a small group of people, but that small group of people has all the elements of civilization that we all understand. So that's a good place to do the exploration.
And I think me and you agree on this, Susan, in the fact that institutions, corporations, they tend to think, that they innovate, but they really actually don't. Governments, they don't really innovate. It's people that they hire to do the creativity, the imagination, the systems change.
Well, if we look a little deeper.
Oh, the engineers. I meant to say the engineers.
There you go. And there aren't that many people who get hired to be innovative, because usually a corporation is making money off its things that it already does well. and
Like,
it
here's
wants
your
to
scope
sell
of
those.
work. This is what you do.
Yes. So the space where innovation happens is a really interesting space. And especially in Western culture and in America, we have this ideal of the innovator hero, right? Our Edisons,
Yes.
our Fords, right? Somebody came up with a new thing. And now in the IT era, we've got all sorts of innovator celebrities, right?
Yep.
And the facts may be a little different than our narrative stories, but the way innovation happens is when you have that really deep understanding that there is no solution, right? Because if there was a solution, then
We'd be
you
doing
should
it.
do that.
Yeah. Yeah. Let's
So
do
you have
that.
to get into a space where I don't know what to do. There isn't any solution.
And that's where, being from North Dakota, that's what I was wondering, as a guy like myself. It's like, well, I know that we can't do this for very much longer. I thought it'd be a couple more years before we got to the point that we're at. Obviously, COVID, I think, sped up a lot of those things, hit supply and demand. But as you said, fracking extended the time period out probably another 10 years. So if we want to have the fracking or the shale revolution, I guess you could say, we would have already been at this point 5 years ago, or longer. And so, like you had said, this is not nothing. The writing has been on the wall.
Yeah, in fact.
But now we're to the point, humans or society, most maybe throughout a long time, they don't really act all as one until we're faced with unprecedented situations that affect our quality of life.
Right. And for the 60,000 years of the human experiment that we are at least have clues about, the way that people dealt with the future was tradition, right? You didn't have a lot of room for experimentation. Somebody came up with cheese, and that
That
really
worked.
probably let the population grow a lot
Grow,
because you
grow.
could
Yep.
store a lot of nutrients.
Yeah.
Wine,
High
okay,
fat.
fun and storing nutrients.
Yeah.
Fermentation, cooking. So we came up with these technologies that let us expand, let us do new things. But the pace was so slow that we could incorporate those new things into our culture and into our traditions so that we could keep things steady, right? So in a particular area of France, they make their cheese exactly the same way every year. Don't experiment with it because they got it down. Got it, figured out. Don't change it.
Stinky
And
cheese.
so we shouldn't be surprised that humans are pre-wired to not change things that we perceive work.
We're creatures of
And
habit.
we're not pre-wired to perceive the pitfalls of what we're doing because it's less risky to go along with what has always worked than to throw that out and try something new. So just understanding what our long-term experiment has been, and therefore how, as societies, we can navigate through this interesting time. I think, like I said, I think that this transition period is really transdisciplinary. And I do think that what is the primary driver for human behavior is the psychologists are right, what other people think. So my tribe, my acceptance in that tribe, again, for that 60,000 year experiment, getting kicked out of your tribe was death.
Yeah.
There's no way to survive by yourself. This idea of being self-sufficient is not a thing. You can fulfill your role within the group, but if they kick you out, then that's it for you. All right. So fitting within your group, social acceptance, accepted behaviors, all that good stuff going along with the story. And there's so many ways that in culture we establish those stories so that we can all be going along with them, right? We all know when Christmas is, for example.
Yeah.
All right.
Yeah.
But then on another level, doing what we know works. That works. And that is engineering, is making stuff work. And when we perceive that the way we're doing things isn't going to work, that's when we become very open to new things. And we become expectant of new things because every time whatever it was we were doing didn't work in the past, somebody amongst us, that 1% of people
innovate.
who observe, who tinker, who, make stuff work, they pop up and they figure out how to make that work. And that's this, I definitely do not believe that that engineers are the heroes in this story. I just know they are the catalyst. That when they jump in, understand that it's changing the engineered systems that nobody else can actually change in ways that work over a long term, then that's what they'll work on. We've all just seen the Mars, robot land on another planet and go running around doing its thing.
Yeah.
That is a lot of people working together from different specialities to make something work. We actually are capable of that, but we do have to be on the job.
Yeah, I'm definitely agree with that. And I understand there's a ton of more people that are much more gifted and talented in their respective, fields. And so what I found is I found a niche doing events. And so whenever I've helped organized or been involved with an event around a common theme, you bring those people together, good things happen, especially if you're focused on that common goal, because then people are thinking about it. So when I seen, you were in energy transition engineering, I had to, reach out. I'm like, well, what does this transition look like? I know that we're in it now. And so, having a lot of oil and gas friends are like, one of their arguments, and this is maybe no fault of their own, maybe, but there's like, well, we use oil and gas to make everything. I was like, yeah,
That's fact.
right now. It's like, but what happens when we run out of oil and gas? We're going to make stuff out of it. And like, we just drill more. I'm like, well, what happens when there's no more? Like, they don't. It's hard to, like, how do you address an argument like that, like, to where I've informed myself and I understand where we're at. But when you're so inundated, and the culture of the oil and gas industry is not really wanting to talk about the problems. They want to talk about, hey, let's drill some more wells. That's been the solution.
If you're talking about problems in a way that isn't a good problem definition, then you're not actually going to get anywhere. You're just going to spin your wheels. So I guess I could give you a preview of the end of the book, where I lay out one of the big transition engineering projects that my group worked on that has an interesting outcome. And it has to do with oil. Okay. All right. So you have an oil company, and it's a big oil company, and it's good at what it does. And it has a really big problem in that it has undervalued its product. We found out in 2007 and 2008 that the world would happily pay $140 a barrel. That's not a problem, right? So like that. How did you not learn from that? Why is oil $60 a barrel? It should be $400 a barrel.
Wow,
think of what it is you're making. It's the most valuable stuff anybody's ever made.
Yeah, the most energy.
At $400 a barrel, you'd be pumping less oil. But then again, if you're pumping less oil, that means you don't have to spend money on exploring, because you know where that much oil is.
Yeah.
And you don't have to spend money on nefarious managing of the message and the risks in different parts of the world that you do.
Yeah. Yeah.
And going up into the Arctic and going into the deep sea. So let's say that as an oil company, it occurred to you that the amount of oil that you already know where it is and what will cost to produce is more than enough for 100 years. Wait a minute. You just saved yourself so much money. And if the price of oil was, like I said, $400, and it could even go higher, and you're producing a tiny amount of oil, now you have triggered society to figure out what it values oil for.
Yep.
Maybe that plastic bottle that your laundry detergent comes in, that might not be the most valuable thing that you would use for oil.
All the single-use plastics.
For someone after an operation, yeah, that's kind of valuable. Right. So you start to get that valuation of oil. If you're an oil company, how in the world like I said, I think you can actually sit down now that you've seen this new world where oil is like that, where it's actually a very valuable thing, and where your company is making a lot of money off producing it. And you can see now gigantic opportunities for what you would go into. For example, if I was the oil company in New Zealand that does the work of refining, distributing product we've imported, we have the fueling stations around. And then we also have a company that does some of the exploration and pumping of oil. If I was those companies, I would get together and I would say, okay, let's make a plan to get to this new world where oil is expensive. We're not producing very much of it. And in that new world, what I see is that I want to be the company that actually owns the tram network in our big cities. And so I think I'm going to do that. I'm going to move laterally into areas where I know cheap oil is going to open up a void for what comes after cheap oil. And those places like electric tram networks that run around our cities, that move goods to our markets, that these electric trains, that the reason they can't be built in cities right now is because our city councils, regional councils, have no capability to do that. I want to compare building a street tram network for our big city of Auckland with building an offshore platform in a refinery. And I know who can build that tram network with half a brain.
Yeah.
They need a bit of retooling, but it's those kind of system mechanical engineers and electrical engineers, along with civil engineers and operation specialists and project management and supply chain procurement. They can do this. And why have we not got that before? Because like I said, our cities are not capable of building them. And because of the competition with cheap oil in our individual cars. Well, that's number one thing we know has to go to mitigate climate change. So if you happen to be in control of the competition of your new system where people will pay you for a trip twice as much as they'll pay you for a liter of fuel.
Yeah, the subscription
Wait
model.
a minute, these numbers are really crazy. Why don't we do that?
Yeah, it does make a lot of sense. And when you think of like to say the Treasure Valley, like here in southwestern Idaho, we're the 5th largest, fastest growing metro in the United States, and 6th economy. We were ranked number 6 on the top most impactful or growing economies in the United States. And so it's like if there's a place that's going to implement these things, I mean, Boise, I don't know if you're familiar with it very much, but they call it kind of like a small Denver, like little Denver. And so like their solution to all this growing is, okay, we need to widen our highways, we need to build more roads, to where it's like, what is the role of public transportation and electrifying that grid that like you're talking about, to where we have, maybe not necessarily trains, it could be trains, but just where.
Well, that's the most efficient. And having looked into transport a lot.
Yeah.
The fixed rail transport is massively efficient. It can be run on electricity. And that electricity can have an oil power plant that lets it manage using wind. Because with this variability of wind, you've got to have something that balances that. And the transport networks with modern IT, see, usually when we think about trains, we think 1800s trains or something.
Yeah,
we think
BNSF
old school
railroad,
trains. Remember, they didn't have computers in the 1800s. They didn't have GPS. They didn't have customer interface. They didn't have tracking. They didn't have blockchain. There's a lot of things they didn't have.
Yeah.
And if you layer all of that capability into electric traction, what you see is that your power grid problem is more or less solved because you have dispatchable load now to match your undispatchable resource. And you can back that up with an oil power plant so that you can maintain the grid integrity. You don't have to feed the oil power plant very often, but it now forms a thing that makes sense. So your little oil and gas variable power plants. But what you need in order to actually use wind and solar is a dispatchable load. And if you think about moving around freight and goods, you'll hear people kind of dismiss rail in that, oh, well, it's not fast enough. But you don't know what you're talking about.
Yeah. Yeah. I mean,
Freight does not depend on speed. It never does. It's not a thing.
It depends on consistency, really.
But not even that. It depends on being able to get from point A to point B.
Yeah, I mean that's what I meant by consistency. Like it's just got to get from there to there.
Just being able to get there, that's what it depends on. And if you can track it, then you're kind of done. So you can be very opportunistic in how you run an electric rail, electric goods distribution in the city. Think of trams, but with curtain-sided trucks on the tram lines. And you can also pick up rubbish that way. You can pick up the garbage and move it back out of the city that way. So that's really the future continent, this new world where we use the renewable sources that we have for what we actually need to do. And then once you've got fixed transport assets, which is, until fossil fuel, what the world was. So our entire way of understanding civilization is built around fixed transport assets: ports, rivers, wagon trains, but mostly ports, and then trails. And then when rail came in, now you open up whole continents to those fixed transport networks. Yep. And those fixed transport networks, that is why Denver exists, because that's where the rail came.
Big hub. Yeah.
Yep. So what fixed transport systems do is that they grow the civilization around them. You're not going to get sprawl. And okay, I think we'll survive without sprawl. Yeah. We actually need to stop sprawl now, and we need to reclaim a lot of sprawl for agriculture. So that was a failed experiment of, the 50s onward as a way to keep the demand for oil going up. So that was a big mistake. And that's part of that regenerative work that we have yet to do. So putting in fixed transport infrastructure, like trams, trains, and those kind of networks, is the way we define the world we're going to go to. And if you look at how long those assets last, how much work they do, how efficient it is, it's really, that's the future there. Learn to love your trains.
Yeah. And
ships, ships, yes, but that's just too obvious for anybody, right? But
for sure. And I was in Europe early 2020. I was in the Netherlands. And I realized that their public transportation system was much farther along than places that I had been, and their trains are super efficient, their buses are great, and so it's like for us here in the United States, we have this affinity for the recreational driving. It's like just like, oh, we need to have a car. If I want to go to, 500 miles away, I'm going to need a car. And it's like, well, you actually don't need a car to do that, because you could either hop on a plane or, you could take a train. But
well, if you had a good rail network, like in Europe, there's an awful lot of trips that you would not take a car.
For sure.
Because they have train networks.
And is our old train infrastructure, rail infrastructure, is that repurposable to go electric, or do we just have to build another system?
Well, it's massively repurposeful because you already own the right-of-ways.
Okay.
Right. So those right-of-ways exist, and that's the path of least resistance. Also, your previous world grew up around those railways. So it turns out they stop at every town. They stop at every place of importance. And they converge on every place of importance, like Cheyenne and Denver and
Williston. That's where I'm from. We had Amtrak and BNSF right there. And that's how I think that's why we were the boom town, is because we had the train, the rail.
Yep. And you can move anything by train. It's just, it is... when you visit 2121, when you go 100 years in the future, that's what's there. Now, being able to move around without having to get on a train, I think that e-bike is the absolute game changer there.
Definitely.
You know, you just have complete mobility, and you don't need very much land to do it, as opposed to with vehicles.
And speaking, like
So
I moved
yeah, we'll make
downtown.
that transition away from owning personal vehicles, and that will essentially save our civilization.
For sure. Well,
I know,
that's
doesn't
very
seem like it
bold.
right now, but
No, but no, it does though, you know, because even for me, I'm in a place in I live in downtown Boise, and my car usage has gone down like 90% over last year and the years before, because now I'm able to go down to my office downtown by bike, and I have a green belt that is 2 blocks away from me. I hop on that. It's very leisurely and therapeutic, and wakes me up in the morning. I'm excited
oh
to do
yeah.
it. You know, so it's like a
Yeah,
huge
and here's the
difference.
thing, like people will then come back and say, oh, but not everyone can ride a bike. There's a thing called engineering. And
Yeah.
I'm picturing in my town of Christchurch, New Zealand, where I was in the early 1900s, there were 75 bicycle manufacturers there. There was a lot of people employed in making bicycles, and it looks like they would make a bicycle for a customer. So people would come in, you get measured, you talk about what kind of bike you want, what you do, and they would make you a bike. Why would that not be a thing? Why would you not, you know, if somebody's not really steady, they can get a three-wheeler. If they need to carry a bass guitar, they can get a wagon for that.
Yeah.
The ability to do that engineering and manufacturing locally of something as essential as a bicycle, why not? And the other thing is, you can build your own trams, you can build your own trains, you can maintain them. You think about, oh, we want to buy electric vehicles, that's the answer. Not really. You got your electric vehicle. I just went down to the used vehicle shop, and I saw a bunch of 5-year-old Nissan Leafs that apparently nobody would buy because they have a range of 80 kilometers now. And yeah,
I had
this
this.
can't be the future, something that only lasts 5 to 8 years. And then we have to
No.
do what with it? Whereas look at San Francisco, look how long electric trams run and work.
Yeah. I
And
just had this.
forever.
I had this conversation with somebody, and even at the range of 80 miles an hour, if you're in the city, that gets you where you need to go. But people, it's that leisurely thought, or that cultural thought that you were talking about. You know, traditionally we've been able to drive across the country and it'd be fine. You know, and so changing that paradigm of, well, if I need to go across the country, I'm just going to fly there and I'm going to rent something, you know, that's where I needed to go. And so it's
Yeah, I again, having lived in Europe, taking the train,
train.
you
Yeah,
know, it'll take me really not much longer than flying. And while I'm on the train, I can get up and move around. I have a whole table to myself.
very comfortable.
Yeah. And I don't have to do that whole airplane thing of getting there 2 hours ahead of time, getting herded through this and that. And so just if you really have to travel somewhere, or if you really want to travel somewhere, um, just talk to somebody who's lived in France or Germany, or these, or Switzerland is actually one of my favorite ones. Holy smokes.
I've only
Um,
flown over.
they do so, and they've got tough geography. Yeah, they've
Yeah,
got some pretty tough geography to
jagged,
get through.
big mountains. Went from Amsterdam to Milan, and I was, you know, luckily I had a good window seat, and I was just kind of amazed that they got lakes and lake mountain. You know, it looks really amazing. You know, but
Yeah. And
so
then there's the other thing of, again, once you get a fixed transport network in, you know where it is. Now you know where your developments go.
yep.
Because
Oh,
if you look at the quality and the longevity of the houses, the shopping centers, the a lot of the commercial real estate that's in the US, if you go to 2121, I challenge you to see that that's still there. It was not made for more than about a 30, 40-year life. So a huge amount of the property we've now got in our urban areas has to be rebuilt over the next 100 years. And when it's rebuilt the next time, it needs to be rebuilt for permanence. You know, it'll be there for 600 years the next time. And when you do that, you want to make sure that where you're building it is where somebody's going to want to be for the next 600 years.
For sure.
And that's where the fixed transport infrastructure is essential to actually get building of our colonial, new, fresh, crazy, boom and bust civilization.
Yeah,
to
and
actually fit permanently into our lovely country.
like when you were talking about the, you know, it's kind of the stopping, mitigating the urban sprawl. I call it like urban villages. And so when you have the backbone or the core infrastructure being that fixed transportation system, and then you have a high density mixed use, you know, type of living situation, is that where the future has to go?
Yes, yes. So you have walkability to like 85% of your activities in your village, your place. It's connected to other places, especially the central services where occasionally you might have to go for court or for licenses or for sporting events, connected to those places by rail. And yeah, it's sort of a distributed model a bit, but with connectivity, I think COVID has really shown us a glimpse of what this, you know, this future continent looks like. And if we can just be really clear about what it is we build now and how that will work, then that is actually the job of transition engineering, so that we, number one, get it started now. Don't go down dead ends. Don't waste money, don't waste time. And yeah, one of my dreams would be to set up a research center with oil companies and all of the ancillary, you know, like the Schlumbergers, you know, all the stuff that goes along, all that good engineering that's gone into getting all that oil out of the ground and into the air, frankly. If we put together a center, a research center to support the transition of those industries to building this new world, that would be the absolute best outcome that I could imagine.
So let's try to apply this in a case study. Let's use Texas as the most recent with
Does it have to be Texas?
It has to be Texas.
That's the hardest one.
It's a very difficult one, but they have, you know, they have a deregulated energy industry. They have a public service or a public utilities commission that's kind of runs everything. And they have a race to the bottom economics, you know, to where who's the cheapest provider? How do we fix that?
Okay, well, now you've asked a question that you're going to have to get the book for.
Okay.
Because
good. It's ordered though. It's ordered. It's going to take me a while.
Has a thing that it's called a wicked problem, and it doesn't mean anybody's bad.
Yeah.
It means that it's a wicked problem because it's big and complex.
Yep.
It works, whatever it is, so that the way Texas is doing stuff works. Well, okay, unless there's an Arctic blast.
Or when it doesn't.
Then it is totally unsustainable.
Yeah.
So we know it's at risk. We know it's going to change because it's unsustainable, but we use it for what we need it for, right? It works. It satisfies our needs, but it causes a huge amount of harm. It's destructive to well-being, to equity, to society, to the environment. Therefore, it's got to change. But any way we look at it, we can't figure out how to change it. That's a wicked problem. There is no one technology solution, no one policy solution, no one economic solution that can even make a dent in this thing. It's a wicked problem. Now, in order to work on that wicked problem, we have to define what the essential needs are that it's meeting. Because if it's meeting frivolous needs, then it's a boom and bust thing and it will fail anyway. And I would move on to something else. But is it meeting essential needs? So that's the first step, is to look at the essentiality. And what we might find is that it's way oversized for that. It is meeting a lot of frivolous needs. And
Yeah.
that if we just focus on the essential, that we will find that there are things we can do. And then we will follow the methodology that's set out in the book. Where I got that methodology from was a lot of research and from doing historical research on previous transitions in engineering, where what was being used, so especially around the Industrial Revolution, what was being used was working. It was one of these wicked problems, and then it changed. So what was it that changed? And it was the engineering. It was the engineering inside there. So safety engineering is the example that we use all the time, because in 1911, you had big factories making stuff, making people rich, being the basis for entire cities developing, and chewing through humans.
Yeah.
Right? People were dying in those factories like nothing. And that fact was just the price of progress. You couldn't change it. The people dying in factories weren't keen, but politically, economically, business-wise, socially, it just couldn't be changed. And then it did change. And that change came from within, where engineers came up with a simple method. And it started in Manhattan in 1911, when some engineers got together and said, we think we can do our jobs, but we will do it being honest about what the problems are, and that there are solutions and that we can figure them out. And we will just prevent what's preventable. So we'll look at what went wrong. We'll look at why somebody died. And then we will work to change why that happened. And it's a very simple methodology. It does require honesty, and it requires actually facing the failures.
Yep.
And they decided to do it without asking permission of the factory owners, and
Industry.
without waiting for regulation or being forced to do anything from the politicians. And that's a pattern that I've found over and over again when we have a transition of something that is dangerous and that is really causing harm. Those core elements of the transition come from within.
Yes.
And then later, the government goes, oh, you got to do that.
Yeah, it's like, oh, we know that you guys are on the right track here. Let's talk about what they're doing right. And
right. And the insurance companies notice pretty quickly that those changes are happening, and they're having to pay out a lot less in these big disasters that happen. The workers go along with it because it saves their lives. The factory owners, they're maybe skeptical, but they're making more money than they were before. So, okay. And now companies are, safety is one of the biggest things. Companies don't go against safety, or if they do, they're negligent and they get sued.
Yeah. And so in the case of Texas, you have the energy industry squabbling, trying to blame somebody, but there was a systemic failure. Like natural gas, you had lines freeze up. Wind, you had turbines freeze because they weren't weatherized.
Right.
Nuclear.
So I hope that this massive failure is the thing that actually spurs people, not at the political level, not in the media. The safety engineers never went to the media. They just wrote down the way they were going to approach things. And pretty soon they ended up teaching. Just that little methodology just spread so fast through training of one engineer to another, one factory to another. And like I said, a very simple methodology you can follow. So chapter 4 in my book is this methodology for taking on wicked problems. And so far it's worked. And I think that's really part of it, is to just know that, okay, I don't know what we should do right now, but I believe if I go through this methodology, I get the information I need, I ask people, how does that work? That we will actually get insight. We'll get to this point of insight where where the whole thing looks different now, and we can see what to do going forward. And I hope that my little example of oil companies going into cities and developing and owning the tram networks is one of those. That's very insightful.
And
that
there's
you
like,
can move into transportation instead of just fuels and actually make more money. And that's where the center, I think, would be very helpful, because in the past where new industries are developing or industries are doing new things, they always have this university support to work out the bugs and try different things and come up with the way to do it.
well, that is very insightful because they are already in transportation from a logistics standpoint, but not.
They already know logistics. That's true.
Yeah, I mean, they're shipping it, but they don't own those trucks. They don't own those rails most of the time. So you're telling them to build the infrastructure that they can own and manage, run.
Right. And so they should have people who understand those infrastructures. They definitely have people who understand how to build things and how to get stuff done, how to organize big fleets of things.
Yeah, no,
And yep,
that's a fantastic point. And so one of the things that I also
all they
noted.
need, now figure this out, all they need is the power to go into a city and say, you know what, we'd like to build this tram network, and we've had these guys who really know how to design and lay out trams look at this city and figure out where the trams should go, and we want to build it and run it. Who else on this planet has the power to do that?
Oil industry.
I know.
Mm-hmm. They got the lawyers, they got the lobbyists, all the
They're
infrastructure is in
right
place.
And if anybody complains, it's like, what? What?
Public service, public service.
You want a better world or not?
Yeah, it's like, we're going to do it. And that's a reality. It's like, just because the truth and facts sometimes can be uncomfortable doesn't mean they shouldn't be said. And like with people,
and
if they want to
would attract a lot of young talent.
For sure. Thank you for that, because I had left the oil and gas industry because I didn't like the culture. They weren't forward thinking, they weren't innovative. I wasn't excited. So make it exciting. It shouldn't be that difficult, but there's such a big gap,
Yep.
like to where even with Trump, Biden, these guys are late 70s, early 80s. It's like, the people that I know that are aged, they have enough energy to get up, have lunch, have a meeting, maybe watch some TV, go back to bed. And that's the reality. And so it makes it real difficult to get really fired up about a guy who can't talk to me. He doesn't know how to connect with me.
Yeah, and look at who's at the top of the oil companies and
same age. That's the same group. It's the same group.
Yeah.
It's the same culture, same mindsets. Well,
that's where from within a university, if I could attract enough talent, and especially people who've been in the oil industry and want to retool, then we could actually start to put forward these prospectuses. We could flesh them out, do the numbers, and put them forward. And I'll bet the oil companies could keep their subsidies to explore those new things instead
for sure, or get more subsidies to spur this innovation and engage young people. It's like, and so Susan, you have a gift. So most engineers have a difficult time articulating systems, in a way that connects without getting too in depth or technical. So I believe you have a gift. And obviously, I think you know that you have a gift as well. And so where would people go if they want to buy the book right now and explore all this knowledge and wisdom that you have? Where would they go?
All right. Well, the book is called Transition Engineering. And there probably isn't another one of those yet.
I don't think so.
If you like Amazon, you can buy it on Amazon, or you can buy it directly from the publisher. So just Google Transition Engineering and it should pop up. There are quite a few videos where I talk about different projects and stuff online. And in March, towards the end of March, there's an online course for engineers that's actually launching from Canterbury University. That you can do a retraining in this with a lot of other engineers. And then, that next step of coming together to do the actual prospecting work, prospecting for this new continent that we're going to. I think that once we tip a little bit the balance, where we've gotten over ourselves with being afraid of change and telling ourselves the fun stories about what new technology might come along, we will start to get the attention of universities. Hopefully National Science Foundation will set up an engineering research center where, you know, you can agnostically just do the numbers on all of these different transitions, because we've talked about transport and oil, but there's transitions in products, there's transitions in retail systems, there's transitions in housing, there's a lot of transitions where that engineering is needed. And once we do that, what we've seen in the past is that once you set up University of Colorado at Boulder with an aerospace department, you start to really just accelerate that field because you have the underpinnings of it. You have the education of new people. You have the place where old people can come in and ask questions and get those answers done by research. That really helps.
Well, I think when it starts boiling, when you get into that mindset, you run into commonalities, you develop principles, and those things can
Languages,
be applied, you know, across all these different sectors and industries. And so once that ball's rolling, it's going to be easy, you know, to apply it to all these other sectors, because, you know, we're creatures of habit, you know. So once we get into the habit of this energy transition engineering, or even, you know, the things that are associated with that, that's where that change will happen rather quickly, because then we go from horses and carriages to cars in 10 years.
Yeah, that's what I'm saying. Once you see all throughout history, once there's even just the beginning of the establishment of a field where the underpinning science, the underpinning methodologies work good enough, they can always get better the more that you do them, and they get specialized into different fields as you apply them in those fields. The same way safety engineering now, it's the same underpinning, but it is different in a chemical factory than it is in a machine shop. So it gets tailored, but it's the same underpinning methodology that makes everything work. So in my research, in my career, that's what I decided to do, was to look at these big transitions that aren't going to be able to be made just by substitution, and see if there isn't one of those underpinning changes in perspective and work behaviors and understanding, again, from within, the engineers doing their thing in a different way. And I think there is one. So that, I mean, why not? What have we got to lose?
For sure.
Might as well try that.
I think I got 3 questions so that I can wrap this up. But
okay.
You know, so what do you think? You know, I hear a lot of people talking for and against hydrogen. And so I personally am unsure that it's viable. I don't want to say it's not, but I'm not sure. And so how do you feel about that? Because there's a lot of hype surrounding hydrogen.
Right. All right. Hydrogen. Well, if anybody's not on LinkedIn and wants to go have some fun, go on and follow me and look at it when I explain hydrogen stuff.
Okay.
All right. Well, either luckily or not luckily, back in the 2000s, early 2000s, that was a hot topic. It was a very hot topic. And one of the big reasons was because the military wanted transportable toys. You want energy for all of your new toys that can see what's over the hill, and yeah. And batteries, there wasn't lithium ion batteries. The best we had at the time was nickel cadmium. And rechargeables were really just starting to even be a thing. So a mobile source of energy that was rechargeable or fuelable or something like that for electricity. Why not just use a generator? Clack, 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 clack. You can hear that for 10 miles away.
Yeah.
So yeah, not great for military operations. And so this idea of the hydrogen fuel cell was already well known from space. And so there was a lot of money put into, okay, let's look at the hydrogen. And so I did that. I was involved in hydrogen research. And it was very exciting because you were trying to do things that were just nearly impossible. You were trying to get materials to do things you hadn't done before. You're trying to get thermodynamics, manufacturing. It's just, if you love to work on impossible problems, fuel cells are for you. So is electrolysis. So is the energy system that would use hydrogen. And even in the military context, it was pretty clear that it wasn't going to work. So consider that in the early 2000s, the military was all in on the hydrogen. You got any hydrogen military stuff? No, you do not.
No.
You have batteries. All right. So at some point at that time, I was a material scientist, reacting flows. But before that, I was an energy systems engineer. And so at some point, I sort of backed up and looked at the energy system engineering of hydrogen and the promise and the cars and what we're going to do with it. And it's going to go in your house. And I was like, no, it isn't.
Yeah.
Fundamentally, that can't happen. And so I decided to get out of hydrogen, which in the US was also very difficult. And so when I went to New Zealand, I still worked in hydrogen for a few more years because they were on the bandwagon. And then it went quietly away because it was not actually viable. Why is it a big hype now? Because politicians can say it with their mouths.
Green hydrogen.
Sounds like a solution.
So green.
And it means we don't change anything. And that's what we learned the last time we did with hydrogen. We can talk about it. You can make pictures. You can have workshops. You can have webinars. You can talky, nothing happens. And it is in a lot of people's interest who don't know what they would do if things changed to not have anything change.
Okay.
So that's the best use of hydrogen, is to not actually get on to transition.
It makes a lot of sense. And you kind of touched on my next question, being, with renewables and alternatives getting a lot of kickback, from the fossil fuel industry. One of their main issues they like to talk about is, distribution and utility scale storage. So when you talk about these batteries, where are we with, solar and wind, being able to power their grid in conjunction with large scale batteries?
Boy. Okay. In the US, as in other places, there is a grid. And if you look at the history of that grid and the power engineering that's gone into that grid, the power engineering requirements were reliable service, accessible by all parts of the economy, everyone, affordable. And basically those three things, that we have affordable energy that's accessible to everyone and is reliable. And they built a grid that did that. And that grid could last for another 100 years easy if you treated it nicely.
Yeah.
All right. Then we had demand growth, unfettered demand growth, because we had affordable, reliable, available energy. And every time you plugged something in, it just ran.
It just worked.
And so we sort of had this unconstrained growth. And there's lots of examples of unconstrained growth in nature, and it goes where it goes. Yeah. So we've overshot our grid. We've overtaxed our grid. We've deregulated our grid so it doesn't have to be reliable and affordable and accessible.
Just needs to be
and
cheap.
So we now have these sort of breakdowns of our grid system. Putting a bunch of wind and solar into that system does not fix it. It strains that grid even more. So the future of the grid is another one of these wicked problems that we've got, where you cannot ever talk about provision of electricity, consumption of electricity, as if it's a simple question of technology. That's not a thing. And so we have to get serious. We have to have serious discussions, and we have to be working on the energy transition of our grids and not just trying to sell one thing or another. And primus activitas here, the first thing to do is to understand that most of what is using electricity now is temporary. It's short-lived. If it's a building, it's going to be rebuilt within the next 30 to 40 years. And so everything we invest in now, every product, every building, every house, that design must be for about 80% less electricity demand, which if you change your lights over to LEDs, well, you've done that one, tick.
Yeah, yeah,
If
it's
you
like that's
change
the easiest
to,
one.
put a solar hot water system, well, that's a lot off your demand. So there's and of course insulation and good
Yeah,
windows. You get your energy demand, what you
way
actually
down.
need, way down. And then in the product design, you look for the ability to take advantage of variability. Again, these dispatchable loads. And that can be done in your refrigerator, that can be done in your hot water system, and it can be done in your heating. If you have a well-designed house, you can be dispatchable on those three key loads, which are the biggest loads you've got. And that's what this future continent looks like.
For sure.
So you keep the grid you've got, you run it carefully, and everything that you work on is actually about demand reduction.
Yeah, yeah. I mean, when we talk about peak demand in oil and gas, you talk about peak demand in electricity, and it's like we just need to be much more efficient.
Well,
And I
that's
think
an
that,
unconstrained system,
yeah,
right?
yeah, for
The
sure.
design of a system depends on what the constraints are. A desktop computer, as they came out in the late 80s and early 90s, really wasn't constrained by how much power it could use at all. It wasn't constrained by how heavy it was, and it wasn't constrained by how much of the desk it would take up. And so you got a design for desktop computers that was the old IBM, giant monitor and the big tower and all this stuff. Now, maybe you're too young to remember that. It's
Oh,
possible.
I had a tower. Hmm.
You've seen it in movies, right?
Yeah, yeah,
All right. And then somebody had the idea, if you could take the computer with you, that would be really cool. And you look at the one you've got on the desk and you're like, you're insane.
yeah.
You would need like a car to drive and it would take so much energy. You'd have to have a generator that you drag around with you. And so what you had to do was you had to apply the constraints of the new system that you were going to have, and then you redesign all the other stuff. That's why your desktop computer of olden days drew close to a kilowatt of power, and your little laptop pulls 40 watts. You put the constraints on, you do the engineering. You get elegant, you get efficient, you get energy management. Like if you're not plugged in with your laptop, you'll see that it will have hierarchies of needs. That will shut down things that you don't need. It will slow down some processes. It'll dim your screen because it's trying to run on your battery. So that whole idea of engineering to constraints is where all the innovation is.
Wow. Yep. And it's put that simply, it's like, wow, that makes so much sense. So why don't we do that? And so I guess it's a two-part last question. When we talk about, our event is really looking to identify opportunities, people, ideas. So first we like to look at the challenges. We obviously have big challenges, but would you say is the biggest challenge in energy transition engineering? And then what would you say is the biggest opportunity, in the same breath?
Right. I think they're the same, because
Okay.
the biggest challenge is our own perspective, the way that we define what the problems are, the way we see the issues. So it's our perspective. But that's also the biggest opportunity, because once you change the perspective, now everything looks different, and there's everything left to do now.
For sure. I mean, it's a very simple way to put it, but it makes so much sense that, we're shifting the paradigm, obviously, and it's just simple, and it just makes a lot of sense. But I do have one more to ask, because you did tell me
Uh-oh.
that let me get in one more. You said you had 20 papers on geothermal, and geothermal is very interesting to me, because we're in southern Idaho and there's hot springs all over the place, but I don't know of many, there's some residential stuff going on, I'll admit that, but for larger scale, why isn't geothermal a much bigger thing?
All right. You know that the biggest renewable energy in the grid right now, by far, is hydro. Yeah.
Yep.
Man,
Yep.
does that work?
Yep. Yep.
So you do have to kill a river or two, and you have to build a big thing, but it really works.
Really
All right.
works.
So there's that.
We got a lot of
The
hydro here.
next biggest thing that could possibly be done is geothermal. And the United States has more geothermal capacity than any country in the world, even ones like New Zealand, where we've 17% of our power comes from geothermal. Right. So it's just this quiet thing in the background. If you were to grab 20 people and say, what about renewable energy? 0 of them would say hydro and geothermal. And yet they absolutely dwarf wind and solar, and they're dispatchable and baseload. So there you go. Why don't we have more geothermal? That is a good question in the geothermal industry. America does have the biggest geothermal plant manufacturer. It's called Ormat, and they deliver geothermal power plants all around the world. They have the engineering, they know what they're doing. You also have the drillers and the drill rigs and all of that drilling technology and all of the geophysics and geological engineering to find the resource. It's a specific resource. It's not just down there anywhere.
Yep.
But drilling a well to get at 1 million barrels of oil, do the numbers. What's the payback, and especially what's the payback time? Geothermal. We have geothermal power plants in New Zealand that are 75 years old. Okay, so it's a very long-term prospect, and it's not like big nuclear power plants. They're in terms of big power plants, they aren't big. They're smallish, but they're bigger than a wind farm, and you got one plant.
Yeah. Yeah.
All right, and they will run all the time. So they're a very nice thing. You do have to drill for the resource. And that means you probably have a 50% chance of being right. Doesn't matter how good you are. You probably have a 50% chance of being right, which meant that your upstream risk to get that very nice, very reliable, very long-term renewable energy is way higher than it is to get your grant, slap some solar panels on somebody's roof, whether or not makes any sense, and run away with cash.
Okay.
So it takes more engineering. It takes a lot of engineering. It takes people who know what they're doing to look at the resource, to look at how you use the resource. It's one of the reasons I went into geothermal, because it's a very interesting, complex system with lots of good engineering.
I wonder who has the most drilling engineers.
I don't know.
Somebody who's looking at a pivot. Okay. Well,
yes, somebody who could go into geothermal and who knows heat exchangers and who knows pipes and who knows foundations and knows
foundations, cement, they can do it all.
Exactly.
Well, okay.
So, yeah, there's a lot of potential for geothermal, especially in Africa. If Africa is going to have a reliable electricity, their hydro is going to be exploited and their geothermal, and that is going to be something that people outside of Africa are in a position to speed that up. Also, Chile, Argentina, well, anywhere where there's volcanoes, ring of fire, earthquakes. That's where the geothermal is.
Geothermal's at. Like, so my fiance, she's Moroccan. And so they have a big solar, burgeoning industry there, and they're focused on regenerative agriculture. And so I've been working with some groups that are combining those things with solar arrays to power their pumps, out in their fields. And it's a big, upfront cost because bankers and stuff don't want to finance it, but with the incentives, the tax credits and all those things, it's a 3-year return on investment, here in the United States, but it costs you $500,000 to get into those things. So we're trying to figure out how do we get the government or these incentives on the front end, then we can make this thing mainstream. And so we can help increase or expedite that transition engineering process.
Now you do have to, I think we have to think more deeply about all these things we do. Like I said, hydro there is a price to pay for that.
Yeah.
Right. Ask the salmon fisheries and
Here in Idaho, Idaho is a great case study, and there's people and legislators talking about, all right, let's get rid of these dams. But then, we're one of the states that is best positioned for this clean energy, clean tech revolution, or transition that's going on. But we already have the dams, so but then you have a lot of other people that they want those salmon to have their homes back.
Right. And geothermal has to be done right. There can be minerals down there that come up with the brine that are really quite toxic, and you never know until you've got it. So you do not want fly-by-night people doing it. You don't. Yeah. And when it comes to something like solar and wind, that problem we mentioned at the very beginning of not being able to look forward very far, we need to look forward on those too, and make sure that in the upfront design, they have looked forward at, okay, what, in the 15, 20 years end of life, then what, where does this go? What does it do? What are you going to do with it?
Yeah, being able to make things that are repurposable or reusable.
Something, take that on and get that done. Yeah.
Yeah. Okay. Well, I think we covered a lot here, and I want to thank you so much for taking the time. I'm sure we'll end up speaking again, so I look forward to that. So Susan, thank you so much for being on the Carbon Series podcast with US Energy. And I look forward to hearing more news about your $100 million or 100 million pounds project in Scotland, and wish you guys the best of success with that.
Thanks. It's a big challenge.
It is, and it is. So we're going to be watching that. And once you get rolling on that a little farther, maybe we'll get an update here, and maybe the end of the year or something like that. Okay, Susan, thank you so much for your time, and you have a wonderful weekend.
You too.